Today's video is going to have a quick example of how to solve for all parts of a triangle using SOH-CAH-TOA. So first we see that we have a right triangle here with theta in the lower left hand corner, and this is the given information that we have here. Most important thing that we start with is making sure that our triangle is labeled correctly. So I know that this is angle A. Opposite that side is little a. The right angle is always big C, and opposite that, or the hypotenuse, is little c. And then up here would be angle B, which makes this side little b. So filling in the information, I know that little c is 17.6. Now, going from here, I figure out, probably the easiest thing to figure out is the other angle. So I can do that by going over to my calculator and taking 90 minus 32, and I'll give me 58 for my other angle. So I know that angle B is 58 degrees. Now, depending upon what I want to solve for next, let's say I want to solve for little a. I want to use what's given. I know that theta was given, and I know that the hypotenuse was given. So starting with the angle theta here, 32 degrees, I'm dealing with the opposite and the hypotenuse. Opposite and hypotenuse is sine. So because I know that from SOH-CAH-TOA, the sine of theta is equal to the opposite over the hypotenuse. So filling in that information, I know that the sine of 32 degrees is equal to A over 17.6. Now to solve this equation, I simply cross multiply, and I get A is equal to 17.6 times the sine of 32 degrees. Now I have to make sure in my calculator that I'm in the correct mode, so I check, make sure that I'm in degree mode, which I am, and then all I have to do is put 17.6 times the sine of 32 degrees, and I will get my length. And remembering that I have to go to 3 decimal places, I know that A is equal to 9.326. I could round it if I needed to, 327, but I can truncate it as well. So I can fill in 9.326 right here. Now I want to solve for B, and again, according to where theta is, B is the adjacent side. So given the hypotenuse, the trig function that deals with the adjacent hypotenuse is cosine. The cosine of theta is the adjacent over the hypotenuse. So I can set this up as the cosine of 32 degrees equaling the adjacent side over the hypotenuse, which is 17.6. Again, I can cross multiply, and I get B is equal to 17.6 times the cosine of 32 degrees. I go back to my calculator, and I have 17.6 times the cosine of 32 degrees, and I wind up with 14.925. So B is equal to 14.925, and I can fill that in here. And one thing that's always good is you want to check to make sure that the smallest angle yields the smallest side across from it. So 32 degrees is my smallest angle. That should mean that side A is the smallest, which is 9.326. Likewise, which we would assume that the biggest angle, 90 degrees, which is the hypotenuse, is right across from it, should have the biggest side, which it does. So there's a quick example using SOH-CAH-TOA to solve for all parts of the triangle.